Can you tell what all these shapes have in common? They are all what's known as conic sections. We are surrounded by them, and we can find them everywhere in nature. They are quite useful too. From helping us build to helping us understand how planets orbit in space, conic sections are very important. They can be seen in so many fascinating ways and places, and I am going to show them to you today. An easy way to find conic sections is by cutting up cones like these ones. We will find a circle with a slight tilt. We find an ellipse parallel to the side of the cone. We find a parabola, and at an almost vertical angle, we find half of a hyperbola. But conic sections are a lot more interesting than all these cut up cones. They share many similarities that aren't noticeable at a glance. In fact, the only difference between a circle and a hyperbola is the distance between two special points called the foci. Let me show you. When the foci are overlapping, and we take the sum of their radii, we find that it makes a circle. We can show this using a binder and a flashlight, like this. Now when we take the two focus points and we move them slightly apart, and we take the sum of the focal radii again, we will find that it's more an ellipse. We can also show this using the binder and a flashlight by moving the focus points slightly apart. Oh look, it makes an ellipse. What if we were to move the two focus points so far away that one of them was at infinity? We can do this by pointing the flashlight up to infinity. Here we see that we have a parabola. But what if now we inclined this plane even farther, so that it was even farther than infinity? We find a hyperbola. You may have noticed that the farther away we move the two foci, the less circular our conic section was. To measure how uncircular your conic section is, let me show you how we measure something called eccentricity. The more eccentric your shape is, the less circular it will be. Therefore, logically, a circle should have an eccentricity of 0. To do this, we must first draw the axis of symmetry and draw a line through the focus points that is perpendicular to it. Now we must draw the focal tangents and draw a line also perpendicular to the axis of symmetry called the directrix. Take any point on the shape and measure the distance from the focus point to that point, F, and from that point to the directrix, D. To find the eccentricity, we must divide F by D. In a circle, the two tangents are parallel, so they meet at infinity. The eccentricity is F over infinity, or something infinitely close to 0. In an ellipse, F1 is shorter than D1, so the eccentricity is less than 1. In a hyperbola, D1 is shorter, so the eccentricity is more than 1. In a parabola, they are equal, therefore the eccentricity is 1. But how can all parabolas be as uncircular as each other and have the same eccentricity? It is all a matter of perspective. The more zoomed in you are, the more circular it appears to be. For understanding conic sections and eccentricity, visualization is the key. So I hope that this video has been illuminating and has helped you see conic sections in a different light.